don't know who Aviatrix is, but then I'm going to drill into something called a distributed cloud firewall that a lot of people aren't really familiar with yet, but you'll see is really great for the cloud, and it helps people rethink, what network security for the cloud should be, because we've done a lot of lifting and shifting of last generation technologies into the cloud, but there's a whole new dynamic in the cloud that needs to be thought out. So with that, let me just get started here. Oh, it's not going. There we go. So just a little bit about Aviatrix. Aviatrix was founded in 2024, and in 2018, we were actually the transit gateway in AWS introduced their own AWS transit gateway that everybody's used to now. So in 2019, what we did is we essentially expanded the capabilities that we were doing in AWS and made our product work in Azure and in Google and in Oracle and in Alibaba clouds, so that you could have consistent networking, cloud networking across all of your clouds. In 2020, we started embedding security into that cloud network. And so now we changed our tagline to Secure Cloud Networking. And in 2024, we have over 500 enterprise customers, over 50 of the Fortune 500 in 25 countries around the world, ranging in size from 10 to over 5,000 VPCs and VNets in terms of the size of these deployments. So we've been around for a while doing some pretty cool things. These are some of the customers that we work with, just to give you an idea of the kinds of customers that we're working with and building their cloud networks out. So what we are is a distributed system, a programmable distributed system that has a control plane, and then that control plane deploys what we call micro gateways that go throughout the multi-cloud infrastructure. And this is how we do the embedded telemetry, the embedded security. It's a cloud operating model, so these things spin up and down automatically. It is a distributed system, so you're not managing these gateways all individually. It's done as a distributed system. It's consistent across all of the environments, and as I mentioned, it's proven at scale. So in 2020, what we did is we took advantage of this distributed system and the fact that we are the data plane to be able to embed security into it. We started that with what we call Threat IQ. And what Threat IQ did is essentially looked at the source and destination address of each one of the packets and compared that to a database of malicious IPs. Now, we don't make that database. It's made by Proofpoint, the same people that do that for AWS, GuardDuty, and so forth. But what we did is we're able to see anything in our customers' clouds that are talking to malicious IPs. And you get all these little red dots. And we had all kinds of customers go, what are all these red dots? Because our other security solutions aren't seeing anything. And it turned out they found Bitcoin mining and Tor servers and botnets doing DDoS attacks and all kinds of stuff that none of the current security stack was seeing, because the traffic simply wasn't running through the inspection points. So we'll see how that changes over time. The other thing that we did around security is we helped our customers and our partners bring their last generation firewalls into the cloud and do that in a very simple way. And this is a centralized architecture. So we made it so that you could bring those in and we would handle all of the routing, complexity to get the traffic down to those central locations and so forth. So we still do this, and we have a lot of customers that support their Palo Alto firewalls, their Checkpoint firewalls, Fortinet, F5, all of these with this kind of cloud architecture. But in May of last year, we introduced what's called a distributed cloud firewall. So what this does is it takes advantage of the fact that our data plane is seeing every packet that's flowing through the network. And this allows us to write a policy for looking at that traffic. And then that policy gets actually pushed out into the distributed system. Now, the nice thing is we don't push every policy to every one of the micro gateways. We only push the policies that would affect the traffic that's running through those gateways. And the way that we do that is we create what we call smart groups. Now, what a smart group is essentially a way to define what it is you're looking for that this policy applies to. So in an example here, we're going to use AWS WordPress web applications. So this is looking at resource type virtual machines in the environment tagged production, in a role that is a web role, in the application WordPress, and in the cloud AWS. So you can create these native tags and attributes to define exactly what you're looking for, and then you can apply the policy to it. Now, the nice thing we do here is that we take advantage of native constructs like the AWS Cloud Trail, Azure Monitor Activity Log, the GCP Cloud Audit Activity Log, and we're monitoring that log. So if anything changes in the environment, we will move the policies to where they need to be automatically. So you don't have to deploy and then decide, oh, I'm changing my application, I got to move these policies around. And we push the inspection and the enforcement out into the natural path of traffic. So now you're not routing traffic down to a centralized firewall. You have a centralized policy creation, but you're doing the inspection and the enforcement actually in the natural path of traffic. So I might push a smart group A just to these two endpoints here because it's an AWS WordPress app. I wouldn't push that policy into the other clouds, for example. But I could have a multi-cloud policy that would get pushed across multiple clouds out there. Now, another nice thing is it's not just about this architecture isn't just for firewalling. So you can do IDS, you can do vulnerability scanning, you can do URL filtering, and we even do microsegmentation, meaning that we will push a native security group all the way into the VPC. So if two workloads that are inside of a VPC or VNet, you want to apply a policy to how they can commute or communicate, we can push that in using the native security groups, because that traffic between those two workloads isn't going to actually run out across our data plane. So we wouldn't use our micro gateways in that standpoint, but we can use the native constructs to go all the way into the VPC or the VNet. Now, I want to give you an idea of the price performance architectural comparison here. And what I'm using is a customer of ours that had 290 VPCs. And I'm comparing what they were spending essentially and what the performance is on a centralized last generation firewall architecture versus the distributed cloud firewall architecture. So basically, you had 30 Palo Alto Networks firewalls to cover those 290 VPCs across 5 regions. Now, with the Palo Alto firewalls, it requires a M5N, 4x large machine underneath each one of those instances. So it was costing $15,412 a month for just the underlying compute, not even the firewall licensing. Now, comparing that to a distributed system, we have 580 of those micro gateways, and don't freak out. I mean, people freak out that there's 580 of them, but you're not managing it like it's 580 instances. They're managed as a distributed system. And because they're T3 smalls, the cost is only $10,000 a month. So a 33% lower cost. And then if you look at it from a performance perspective, the large gateway sizes will give you 7 gigabits per second, and the micro or the T3 smalls will give you 5 gigabits per second. But if you look at that in aggregate, you're getting about 210 gigabits per second of aggregate throughput through your security solution versus in a distributed solution, you've got 2.9 terabits of bursting capability going across there. The other real benefit here is a large failure domain versus small failure domains. We've seen a lot of customers that have actually had their firewalls cause more downtime in the network than actual security problems in the network. And that's because a centralized architecture, if the firewall goes down, all the systems that are going through it are going to go down. And with the small failure domains, if you're distributing, you actually only have things go down in a particular VPC or VNet, if that even becomes a problem, because this is all using different availability zones and so forth to cover that.
Hey, Rod.
Yes.
Rod, yeah. I've got Seth, who is one of the leading IT security people in financial services, worked at Barclays and others. He had a question on how you work with Zscaler. Seth, do you want to add anything to that?
Sure. So, I mean, Zscaler has their own cloud proxies, their own distributed network, their own micro, segmentation. So I'm curious as how you integrate with those and what synergy is there between you and something and a SASE ROA like Zscaler.
Yeah. We have a lot of joint customers with Zscaler and Cloudflare and others that are doing things like SASE, which is really access coming into the cloud, right? And looking at the user authentication as you come into the cloud. We are doing more inside the cloud. So the workload to workload, service to service communication that happens so that you can do that segmentation actually inside the cloud rather than just protecting at the edge of the cloud. And so what we do is we partner with them. There's their connector that comes into the cloud, then just connects into the Aviatrix cloud network. And as you've seen in the pictures where all the balls are flying around, we would connect at one of those little blue dots that you see in the background, and then the traffic would come through. We're then just doing the protection that you would otherwise do for east-west firewall inspection inside the cloud. Does that make sense?
Yes, thank you.
All right.
Excellent, Rod. We've got about 5 minutes. I think the key theme I'm hearing is the real power of Aviatrix is that you're saving people the hassle or the risk when they're trying to integrate on-prem security, traditional security with cloud security, and you're making it easy for everyone to have the same security they require without having to worry about re-authenticating or reconfiguring their systems. That's
and I think it's also Ron, a difference in architecture. So this is not the architecture that people built in the data center where we had a perimeter, for example, and we had a DMZ, and we could basically run everything through a centralized firewall that was running on hardware that could, handle that throughput and so forth. As you move to the cloud, you actually have no perimeter. Things go in and out from everywhere. It's not going through a single location unless you force it to go through that location with a centralized architecture, which is essentially a lift and shift of last generation architecture into the cloud. But in the cloud, things are built in a much more distributed way. Applications are distributed. There's no perimeter. Things go in and out in a lot of different locations. So having an architecture for doing network security that actually pushes and distributes that inspection and enforcement into the natural path of traffic in the cloud is a better architecture for cloud than trying to put the data center architecture into cloud, if that makes sense. So I want to just finish a couple more slides here that'll show another big savings we're seeing with customers, and that is basically reducing costs based on NAT. So everybody knows what NAT is, communicating out and so forth here. What we're doing for a lot of customers is upgrading their NAT gateway with an Aviatrix NAT gateway. And we have customers that we're saving $5 million a year because of the data processing fees that the cloud providers have on their NAT gateways. We even found one customer that was spending nearly $1 million on one NAT gateway because it was connecting to their data lake. But what we do is replace the NAT gateway. We don't have those data charges, and we can add security. So a lot of people start with just visibility, what's going through the NAT gateway, but we can add that distributed cloud capability for egress filtering, and it's a way that people start using this capability. And we can do that in a way that we don't even have to replace the networking capabilities in these clouds. It's a non-disruptive deployment. So it's a very easy path where you can start with reducing your cost by upgrading the NAT gateway. Then you can add security by putting egress filtering in just for the NAT gateways. Then you can move to the full distributed cloud firewall. And at that
Everything
point,
going okay?
I'm sorry? Start taking a bite out of your last generation firewalls. So that's the end of my presentation.